Good evening to everybody.
Good evening, sir.
So today's session will be for the student who are appearing for the AMC 8. So it will be a slightly basic session. I'm not saying that any student who are in appearing for 10th and 12th, they cannot attend. They can also attend it, but of course it will be very basics. So let's get started. I will suggest to please switch on camera so it will be easier for everybody. Okay. So today's we'll try to see the basic things, factorization and expansion of the brackets, right? So few points I'm writing it. You have to tell me that what exactly all of you know this or not. For example, a plus b whole square, that is the a square plus 2ab plus b square. I'm sure everybody knowing. A plus b the whole cube. Anyone can speak out? A plus b whole cube. Anybody can speak out?
A cube plus 3a square b plus 3b square a plus b cube.
Yes. A cube plus 3 into a into b is 3ab square plus 3a square b plus b cube. That is a plus b power 4 also we can tell. Other things also we can tell. There is no problem at all. It's just expansion. That is called the binomial expansion. So what will be a plus b plus c whole cube? A plus b plus c whole cube. If there are three terms.
Sir, we can group A and B and call it as one term and C as other term. Then we can apply A plus B whole cube.
Okay, can we generalize it?
So we can simplify the A plus B whole cube identity so form.
Okay. Okay. Anybody else? This is, you can remember this way, a square. Oh, I asked a plus b plus c whole cube. That's what we can see, a plus b plus c into a plus b plus c whole square. Whole square, you can expand it. That is the general case. Same as a general formula of this. So we can say a square plus b square plus c square and then take 2 at a time. Means 2ab plus 2bc plus 2ca. And further we can multiply and we can get the generalized things. Another point. So let's start with this simple question. As the problem, while problem I will be discussing. So first I'm starting with the divisibility based problem, right? So prove that n into n plus 1 into n plus 2, where n belongs to natural number. This means belongs to natural number is divisible by 6. Anyone can give me idea how to prove that it's divisible by 6?
You know that one of the three numbers n plus 1 or n plus 2
Hmm.
will be a multiple of 3. So suppose n is a multiple of 3, then n plus 1 and n plus 2 will be divisible by 6 because the whole product has one factor as 2 and one as 3.
Very
One
good.
will be even and one will be divisible by
100% correct.
Or
That-
we could also use proof by induction.
Proof by induction. Okay. Anybody having any other method? See, we can use the Euclid division lemma. What is the Euclid division lemma? Whenever any integer I'm dividing by a, so some quotient will come and some remainder will come. So Euclid says that ki b, any moment of time we can write aq plus r, where a, b, q, everything is the integer. R will be remainder, and remainder always lie between 0 and a. It will be less than a. That means this is a very powerful tool. It's a very small thing, but very powerful tool. If I say any number I'm dividing by 3, so some quotient will come. What the quotient, I don't bother. But what the remainder, possible remainder can be happen what? What is the possible remainder?
0, 1, 2.
0 or 1 or 2, because R will always lie between 0 to A, less than A. A means less than 3. So this is the only possibility. Means every number in mathematics, we can write either 3q format, with 3q plus R, or 3q plus 1, or 3q plus 2. Every number, any number, if you see, this will be any one of this format. It means if you take 3 consecutive integers, at least one will be multiple of 3. At least one will be multiple of 3. If you take 3 consecutive integer, at least one will be multiple of 3. Similarly, if you take a 2 consecutive integer, at least one will be multiple of 2. Now, here these are 3 consecutive integers. So at least one will be multiple of 3. So 100% sure, we can say 3 is the factor of this. If 3 is the factor of this, and there is a 2 consecutive integer, and 2 consecutive integer is always multiple of 2. So this is the divisible by 2 also. So this number is divisible by 3 and divisible by 2 according to the Euclid division lemma. So we'll say that this will be always divisible by 6. I hope everybody understood the point. Another question. See, if anything's not able to understand, please let me know. Another question, try to prove it. Prove that cube of 3 consecutive integers always divisible by 9. By 9. I'll give you 2-minute time. Please try and tell me, those who got it. Cube of 3 consecutive integer is always divisible by 9. Prove that sum of cube of 3 consecutive integers is always divisible by 9. If anybody got, please let me know. Three consecutive integers, sum of cube of 3 consecutive integer is always divisible by 9.
Yes, sir. Done.
Done?
Yes, sir.
Good. So suppose let numbers are
So n cube, n plus 1 cube, and n plus 2 cube,
yes,
whole cube.
n cube, n plus 1 cube, n plus 2 cube. So let's suppose sum is representing s. So that will be n cube plus n plus 1 whole cube plus n plus 2 whole cube.
So which is
Expand it.
3n cube plus 9n square plus 15n plus 9.
Yes, let me solve it. If you expand it, there is the n cube, here also n cube, here also n cube, n cube. Check it. Here 3n square will come. Here will be coming your 6n square. So it means plus 9n square. Here 3n will come and here 12n will come. So 15.
What's the word after 3 in the question?
Pardon?
So what's the word after 3 in the question?
3 consecutive integers.
Okay, sir, thank you.
And here 1 is there, here 8 is there, so plus 9. We have to, our target is to prove that this is the divisible by 9. Now, in this, we have to manipulate in such a way so that every term should become divisible by 9.
Sir, it's 3n cube.
N 3n cube, yes, 3n cube. So,
No, sir, not in the first equation. They all add to form 3n cube. In first equation, there is only n cube plus n plus 1 whole cube plus n plus 2 whole cube.
yeah.
Yes, sir.
This is the calculation is correct? My calculation is right?
Yes, sir.
Okay. So, this term, these two terms, no problem. And these two terms keep together to 3n cube plus 15n plus 9n square plus 9. From here, I can take 3n common. I will get n square plus 5 plus 9n square plus 9. This quantity already divisible by 9. This is also divisible by 9. And this is divisible by 3. If I can prove that this is divisible by 3, this is also divisible by 3, our question will be solved. So how should we deal with this? N square plus 5. N square plus 5. Can we manipulate something so that key 5 should come?
So, 3n into n cube n square plus 5 in this. So we have to prove that this is divisible by 9, where we already have 3 into n square plus 5. So it is divisible by 3. So we have to prove that n into n square plus 5 is divisible by 3.
Yes. This quantity already divisible by 9. This is also divisible by 9. This is divisible by 3. So we have to, our target is to prove that n into n square plus 5 is divisible by 3. That is our main target. We have to prove that this is divisible by 3. Okay. So what is the possibility can be happen? N may be even integer or n may be odd integer. Anything can be happen. So in both the situation, we have to prove that this is the divisible by 3. So anyone can have the option to prove this one.
Now we can write n as 3n or 3n plus 1 or 3n plus 2 by Euclid's division lemma. And then we can put the values of 3n, 3n plus 1 and 3n plus 2. And
It will be too lengthy. It will be too lengthy. All 3 cases we have to do. N equal to 3m, this is true, no problem. It will be 2. N equal to 3m plus 1. I'm going by that method, what he is saying. But still that is a lengthy actually. If I'll put 3m, so n square will be what? N square will be 9m square plus 6m plus 1. So n square plus 5 will be 9m square plus 6m plus 6, which will be divisible by 3. This is divisible by 3.
Yes, sir.
So other possibility, n equal to 3m plus 1, 3m plus 2. If n equal to 3m plus 2, so if you're putting here, so n into 3m plus 2. 3m plus 2 whole square will be 9m square plus 6, 12m plus 4 and plus 5 already there. So this is again 3 will be one of the factor. So this will be always divisible by 3. This will be always divisible by 3. So we can say this total will be always divisible by 9. Is everybody understood?
Yes, sir.
We can make it a little bit more simple by manipulating the something, these three something here. I'm just giving another method. From these three, I can taking 3n common. If you'll take 3n common, what will get? N square plus 6n, 3n plus 5 plus 9. Now s equal to 3n into n square plus 3n plus 5. Do we have chance to factorize? No, we don't have chance to factorize. But we can do something. N square plus 3n plus 4 and minus 4 if we do. It can be done from here also. Plus 3 plus 2 we can take it. Wait a minute. We can manipulate. Watch carefully. N square plus 3n plus 2 plus 3 I can write it. And we'll get what? 3n into this can be factorized. N plus 1 into n plus 2 plus 3 plus 9. Watch it, it's over. So we'll get 3n into n plus 1 into n plus 2 plus 9n plus 9. Now this is always divisible by 9. This is also divisible by 9. And these are three consecutive integers. Three consecutive integers. Surely one of them will be 3n format, 3q format. So this will be always divisible by 6. Or I can say 3. So 3 into 3, this will be also divisible by 9. So this way also we can do.
Okay, sir.
This way also we can do. Other things is that in case of, we did by general way. Other way we can do also, this numbers itself from starting, we have to prove with the, it's divisible by 9. So we can take number in the other way. We can take number this way also, 3q plus 1, 3q plus 2. These are three consecutive integers. Yes or no? These are three consecutive integers.
Yes, sir.
If you cube it, the first term will become 9q cube, which is divisible by 9. Plus, if this cube, no, these are 27, I'm sorry. 27. This will be what? 27q cube plus some 9 cube plus 9 27 q square plus 1. And here also if you expand it, you'll get what? 27q cube plus 3 into this square. So 12, 36 q plus 3 into 9, 27 into 2, 54 q square plus this will be 8. Check it. This is always divisible by 9. This is also 9. This is also 9. This is also 9. This is also 9. 9, 9. And 1 plus 8 will be 9. So that two combined will be also divisible by 9. So that way also we can prove it. I hope it's clear to everyone.
Yes, sir.
Another question? If n is greater than 2, n is natural number greater than 2, n is greater than 2, then prove that n power 5, 1 minute, then prove that n power 5, next term what should I do? Minus 5n cube plus 4n, let's take it, is divisible by 120. Try everybody. Can you get it the things?
Done, sir.
None. Okay. One is 28. Anybody else? Check this. N is bigger than 2. First things we'll try to factorize so that we can get some consecutive integer so that we can apply Euclid division lemma. So n, if I will take common, I'll
N
get
square minus 4 and n square minus 1. The
minus
factorization.
5n square plus 4. I think this can be factorized.
Yes, sir.
Yeah.
From n square minus 1 into n square minus 4.
Yes, sir. So which is equal to
Yes,
n minus
it's
n
1
into n minus 1 into n
1
plus 1. n minus
plus
n
2.
minus 2 into n plus 2.
Let's write it in increasing order. The smallest is the n minus 2, then n minus 1, then n plus 1, n plus 2. This is the 5 consecutive integer. It's a 5 consecutive integer. So 100% this will be divisible by 2 and 3 and 4 and 5.
5 factorial 120.
That means the product of this will be divisible by product of this also. That is the 120. I'm not using factorial term. Maybe some of you don't know factorial. Maybe 2 consecutive divisible by 2. 3 consecutive divisible by 3. 2 and 3 both. If I say that there are 6 consecutive, so it will be divisible by 2, 3, 4, 5, 6. All 6. So this will be divisible by 2, 3, 4, 5 because the 5 consecutive. It means it will be divisible by product of this also, and that is the 120. So what we learned that if there are consecutive integers, then it will be divisible by by 2, 3, 4, so on till r. Every integer.
Sir,
Divisible
can
by-
you go a little up?
Pardon?
Sir, can you go a little up?
Yeah. So that's what the meaning. It will be divisible by 2 also, 3 also, 4 also till r. Means it will be divisible by product of their number also. Okay, done?
But sir, even if n is equal to 2, this term is divisible by 120 when the condition
That's why they say that n is greater than 2. Na? By chance n is equal to 2, then it will be divisible by every integer. Not only 120. Suppose n equal to 2, what will happen? The term will become 0.
Yes, sir, but then sir, 0 is equal to 120 into 0. So
Yeah, that's what I'm saying. Then 0 is divisible by not only 120, it's divisible by 109 also.
yes,
It's
okay, sir.
divisible by everything.
Everything. It's every. integer it will be zero. So that's why just to avoid the contradiction, they put up n greater than 2. All right. Coming to the next question. Today, maximum, I'm doing divisibility based problem. Okay. Now, all right, the question. Find all possible natural number n. Find n. N belongs to natural number. Find n. N belongs to natural number. If 5n square, 5n square minus 7n, 5n square minus 7n plus 84 divided by n is divisible by, it's a divisible by 5. It's a divisible by 5. You have to tell what are the possible n value for which this whole expression is divisible by 5. Please type the answer in chat box. No, Urvi, n equal to 3, I don't think it's divisible by 5. N equal to 3, if you put it here, you can put and check, no? If you put n equal to 3, what will happen? 9 into 5, 45, minus 21 plus 84, divided by 3. So 15 minus 7, plus 2, 28. So 15 minus 7 will become 8. And 8 plus 28 will become your 36. and 36 is not divisible by 5. So n equal to 3 will not be valid. Let's do it. First thing is that it should be divisible by 5, so this should be an integer, this whole expression. This whole expression, I'm just changing something. 5n square minus 5n plus 2n, sorry, minus 2n plus 84 divided by n, which I can write, I can make pair, this and this pair. Here, I can say 5n I can take common, and I will get n minus 1 divided by n. And here I can take plus minus 2 common, n minus, it will become your, what will become? N minus 40 something will come. Or let it be leave like this only. No need of writing that much. Plus 84 minus 2n divided by n. So this will be equal to what? N will get cancelled here, 5 into n minus 1 plus 84 minus 2n divided by n. Watch very carefully, everybody. This is already divisible by 5, so we don't have to worry. This must be divisible by 5. If you want that this total should be divisible by 5, this is already divisible by 5, so this should be also divisible by 5. If this is a divisible by 5, so 84 minus 2n by n must be this 84 minus 2n. 84 minus 2n must be multiple of 5m, 5mn. Right? This quantity must be 5 into something n. Otherwise, n will not get cancelled. So from here we can say 84 by n minus 2 must be multiple of 5m. And from here we can say 84 by n must be equal to 2 plus 5m. So n must be equal to 84 by 2 plus 5m. This is the n value. And now we have to check out all possible conditions of this. So from which this should be, this quantity should be natural number. This quantity should be natural number, and as well as it should satisfy this condition. So first thing, 2 plus 5m must be greater than 0. Because if you want this should be natural number, this should be greater than 0. As well as this should be multiple, this should divide 84. I hope getting all of you. N is natural number. So this side should be also natural number. This can be natural number only when 2 plus 5m greater than 0. Or you can say m greater than minus 5 by 2. As well as this quantity should be lesser than 84. 2 plus 5m must be less than equal to 84. Because if this is the bigger than 84, this will become fraction. Means 5m must be less than 82. Or you can say m must be less than 82 by 5. But m is integer. So we can simply say that m should be less than equal to 16, because 16 5 is 80, and greater than, must be greater than 0. Greater than equal to 0 also no problem. Now, what are the possible value of m can be happen which can satisfy this condition? M equal to 0. Suppose m equal to 0. So what will happen? This value will become 84 by 2. 84 by 2. So n value will become what? 42. M equal to 1. So n value will become what? N value will become your 7. 84 by 7. So 84 by 7 will become 12. M equal to 2. 84 by 12. Is it possible? No, it's not possible because this should be a factor of 84. So this is not possible. Similarly, you can count it. What are the possible values? This 84, what is the factor? 84, 1 is the factor, 2 is the factor, 4 is the factor, 7 is the factor. What other possible factor can be happen? 84.
3
3 also is possible.
So then 12, 14, 21, 28.
So 12, 14. So M equal to what is the next value? 2 is M equal to 2, not possible. M equal to 3, 15 plus 2, 17, not possible. M equal to 4.
M equal to 2 is possible, right? 12
How?
is a factor of 84, which gives us 7. 84 by 12, 7.
7. M equal to 2, 12, 2 is possible.
Yeah.
N will be 7. M equal to 3, 15 to 17. Not possible.
Yeah. Yes.
M equal to 4, 20 plus 2, 22. Not possible, I guess. No. 5, 25 to 27.
Then we
Not-
can do that n should be a factor of 84. Then all the factors of 84 can be the values of n.
But then you have to check out all the value which satisfy this condition also, no? So what other value can we satisfy? I think it can be 0, 1, 2, 2, 0 also satisfying. And 0, 1, 2. After that, next will be 47 not satisfied, 5 not satisfied, 6 not satisfied, 7 also not satisfied, 8 also not 8. 8 5 are 40, 42 for satisfied. So 40 to 42, 42 into 2 satisfy. Any other value satisfy? I don't think so. I don't think so. Any other value satisfying. 2, 7, 12, 42. 2, 7, 12, 42. This is the 4 value will satisfy because 9 will not satisfy. Because 9 is a factor of 3 not satisfy. Other value, any other value cannot satisfy. So these are the possible value can be happen. What the way they will ask you question that you find out the sum of all possible natural number. They will ask you the sum of these numbers. Any easy method anybody can tell. This is the, you can say pure manual method. It's not going to be, I just check in up to 8 and after 8 I ignore other values because I know it will not satisfy. After m equal to 8, then other value will not satisfy, I think. These are the values will come. Any other easy way can be done. According to me, this is the answer. This is the 4 answer. Means final answer n equal to 2, 7, 12, 42. These are the values which will be done. Let's see another question. Before going to another question, 1, 2 point you should know. It will be easy for you. X power n minus y power n is always divisible by x minus y for all n belongs to natural number. Second, x power n plus y power n is always divisible by x plus y for all n belongs to odd natural number. Be clear, not all, only odd natural number. Write a question. Prove that 2 power 4n minus 1. 2 power 4n minus 1 n is natural number, is divisible by 15. Very simple question.
N minus 1 is an exponent or is it just minus 1?
Minus 1 is the just subtracted from this total.
Okay.
Sir, in the question,
Hmm.
written P dot T something. Sir, can you just tell what is written over there?
Where? Here.
Next to question, next to Q.
Prove that.
Oh, prove that.
This one.
Sir, it's like um 2 minus 1, which is 1. So everything is divisible here, right?
2 minus 1 is the from this total, not from the 2.
We done, sir.
No, the property which is x minus y, which I've mentioned here above.
Hmm.
So it's 2 to the power of this minus 2 minus 1, which will give us
So,
this.
but that is the main point that you are trying to say it's divisible by 1 only. If that will be correct, then you can say that it will be always prime number, which is not possible.
Sir, can I say?
Yeah, please.
Sir, we can write 2 raised to 4n as 16 raised to n.
Yes, correct,
Uh,
correct.
So then
Done.
we can write 16 raised to n minus 1 raised to n,
Yes,
divisible by 15.
very much correct. Suppose a power mn, the property of exponent say that this you can write this way also. So 2 power 4n minus 1, we can write 2 power 4 power n minus 1, which is nothing but 16 power n minus 1, which again we can write 16 power n minus 1 power n, because 1 power n is also 1. This will be always divisible by 16 minus 1, which you can say 15. I hope everybody understood.
Yes, sir.
Next one. Prove that 3 power 2n plus 7 prove that 3 power 2n plus 7 is always divisible by 8. Okay, let me. 3 power 2n plus 7, we have to prove that is divisible by 8. Watch it carefully. 3 power 2n, I can write 9 power n, agree everybody, plus 7. Suppose this value I can write this way. This again I can write this way. I just added 1 and subtracted 1. Till here, clear to everybody? Which I can write 9 power n minus 1 power n plus 8. 9 power n minus 1 power n will be divisible by 9 minus 1. Is this quantity always divisible by 9 minus 1? Means 8. And this is the 8 itself. Have you understand? 9 power n minus 1 power
Yes,
n
sir.
always divisible by 9 minus 1, 8. And 8 this is the 8 itself. So it will be always divisible by 8. If anyone did not understand, please let me know. Okay. Next. If n equal to A, B, C, D bar. Do you understand? All of you understood the meaning of this? This means A, B, C, D are digits. Whenever we write on bar on the top, it means digits. Then prove that n will be divisible by 3 only if A plus B plus C plus D is divisible by 3. Divisibility rule, I hope all of you know. Any number is divisible by 3 only when the sum of digit is divisible by 3. That's what we have to prove.
Sir, could you scroll to the last question? Yes, thank you.
Done?
So we can expand a plus we can expand a plus b plus c plus d in 1000 a plus 100 b plus 10 c plus d,
Yes. Then
and then we can subtract one of them, so it will give us 999 a plus 99 b plus 9 c plus
yes,
a plus b plus c.
correct. See, n we can write what? 1000 A plus 100 B plus 10 C plus D. I have to check divisibility with the 3. So whatever the 3 multiple, you keep it separate. So 1000 A, I can write 999 A plus A. 100 B, I can write 99 B plus B. 10 C, we can write 9 C plus C. And D already there. This number is always divisible by 3. This is also divisible by 3 because 3 is the factor. This is also divisible by 3. So if n has to be divisible by 3, so all these should be divisible by 3. This is already divisible by 3. This is also divisible by 3. This is also divisible by 3. So surely this must be divisible by 3. Yes or no? So A plus B plus C plus D must be divisible by 3. I'm sure it's clear to everybody.
Yes, sir.
Hmm.
So I
Next,
don't understand why you have put the line over ABCD.
see, this is a way of representation, beta, because if you write simply n equal to A, B, C, D, that means A into B into C into D. Generally, our habit is reading that. The moment when we put the line, it means it's represent the digits.
Digits.
Yeah,
Okay.
that's
Thank
purpose only. If I suppose somewhere in question is coming AB written, so how we read? We never read as a digit. We read
It's
as
a
a
read
A
as
into,
multiple.
yeah, A multiply with. To avoid this contradiction, we always use the digits.
Okay. Thank you.
Okay, just give me a second, everybody. I'm sorry, it was okay. So this is the what conditions we used to. This is the way we can define or derive all the divisibility rule. This rule you can use it, and you can get the divisibility rule for the everything. So one question: prove that 10 power 30 plus 10 power 30 plus 10 power 27 plus 10 power 24 plus 10 power 21 plus 23 is divisible by 3. 3, yes. Very simple question. Very, very simple question. Yes, Urvi, please tell what do you have.
You know that if you expand whatever is in the brackets, you'll
Mhm.
get a huge number, but then there will be 4 ones. One in the 1 power 10 power 30 place, one in the 10 power 27 place, and so on.
Mhm.
You'll have a number with 4 ones
Mhm.
plus 23.
Mhm.
And 4 plus 2 plus 3 is divisible by 3, so it's divisible by 3.
Yes, correct. See, these questions we can write this way: 10 power 30 minus 1 plus.
Sir, or we could do it like 10 to the power of 3 into 10 plus 10 to the power of 3 into 7 and 10 to the power of 3 into 7, and then we take out 10 to the power of 3. The rest will be, and then we can prove it's divisible by 3.
Yes, that also we can do. There is no issue. I'm just telling by this way because maybe powers will be in the different way they can give you. Like here, they can give you 37, something prime number, so that keep taking after taking common also, it doesn't make much difference. So this is the best way to do. The x power n minus y power n formula applying is the best way to solve divisibility problem. 24 minus 1 plus 10 power 21 minus 1 plus I subtracted 4 times 1, so I will add 4 times 1, 27. Think carefully. This quantity I can write 1 power 30. This is the 1 power 27. This is the 1 power 24. This is the 1 power 21. This is divisible by what? 10 minus 1 by 9. This is also divisible by 9. This is also divisible by 9. This is also divisible by 9. And this is also divisible by 9. The whole quantity is divisible by 9. And if it's divisible by 9, so surely it's divisible by 3 also. I'm sure it's clear to everybody,
Yes, sir.
right? So that's all for today. And in the next class, the divisibility case we'll discuss, and we'll discuss for the another modular arithmetic I will introduce, the base questions. Okay. We'll continue in the next session. Thank you very much.
Thank you, sir.
Thank you, sir.
Sir, you will share the
Thank you,
PDF
sir.
of this
Yeah,
class
I'll
in
share the
group,
PDF. I'll share the PDF.
sir, in the same group, right?
Yeah, same.
Sir,
Okay,
will
sir.
you also share practice questions?
I'll send today practice question based on today's question.
Sir, I'm not there on the group. Could you just mail me the group link or something?
Can you send the mail to the concerned office department? They will send you the link.
Okay,
Sir,
thank you,
I'm
sir.
not getting any mails regarding the classes or anything.
Pardon, I didn't get you.
Sir, I'm not getting any mails regarding the sessions.
You are not getting the mail.
Yes.
You are in the group or not?
Yes, sir, my mom is in the group.
So in the group it will be, they are updating the class link and everything, no?
Okay, sir, thank you.
Thank you.